So I'm going to walk you through question number 1 in section 7.3 in that statistics using textbook. So this is about the Kyoto Protocol, and we're trying to say, is there enough evidence to show that the mean CO2 emission is lower in 2010 than it was in 2004 and after the protocol were passed? And we're supposed to test the 1% level. So the 1% level is our cutoff. That's the level of significance. If we get a p-value less than 0.01, we can reject HO, say that the 2010 emissions were lower than back in 2004. In fact, we probably should start right here and say, okay, well, what we're trying to test is, let me see if I can get my pen going here. The claim is that the mean CO2 emission is lower in 2010 than it was in 2004. So to reflect that, we're going to say HO, the mean emission amount has not changed. It's the same as it was in 2004. What was it? 4.87. I hope we can read over the writing. In H1, we're going to say it's lower. So I'm reading that as a left tail test. Hopefully it hasn't increased. Okay, so that's our significance test. I mean, those are the two hypotheses. One issue is we got to check the conditions to see if the central limit theorem will hold. I'm only counting 27 pieces of data, and do they tell me anything about? See, I don't know. They don't tell me anything about the CO2 emissions, and who would really know? So we don't know if the distribution of CO2 emissions per year, is it per country, per capita, I guess, is normal or not. So we're going to do a little work with this to see if it works. So what I did is I got this data into a column, and let's see if I can find my Word document here. See, so I put them into a column. I'm going to select it all, copy pasted it, and now we got to see if we get if this comes from a normal distribution. So back in when we were studying sampling distributions in chapter 6, I helped you do some of the work by setting up this spreadsheet that does a normal probability plot. So I'm going to paste in my data. And then in order to get this spreadsheet to work correctly, you got to sort it. So if you write on this Google Sheet, I'm just going to write, I highlighted the data, I pasted in. I'm going to right-click on that and sort range, and it'll give me some options, and usually that's the default, just ascending. Okay, so it's going from the smallest to greatest. Now if I look at my graphs, well, I'm seeing a right-skewed distribution. So this part of it doesn't make it look like it's a normal, could have come from a normal population. I mean, 27 is a pretty big sample size. And I'm seeing, if I look at my normal probability plot, I'm seeing some nonlinear behavior down here, down on the lower values. That's not following that line really well. It's above and below. So it's questionable whether this is normal data. I'm not totally sure that this test is appropriate. Let's see what happens. I mean, I could do a box plot and double check that, but I'm seeing this probably didn't come from a normal distribution. So we'd either need a bigger sample to do it right. We should really go get a bigger sample size. That would because as you know from earlier, a larger sample size is the sampling distributions are normal. You just got to make sure you have a big enough sample. And I guess a sample of 27 isn't enough to show that. But so that's caution. I'm not totally sure that this is the right test to use. It probably needs to go with a non-parametric test. We aren't going to go there for this course. But so we'll do it. So that's just we're actually going to run it, but know that there's a concern with this. I ought to go look and see what the book says about this. Anyways, okay, so I went to the Rossmann chance applet, because I'm going to run a test. I'm trying to run it for those hypotheses, and I pasted in my data earlier. Maybe I better make sure I pasted in the right data here. So there's that data. I'm going to use it. Notice the mean for that data is lower than the 4.87. But you know how samples behave. It could just be due to random behavior. So I'm going to do a significance test. I'm going to type my center of my distribution is 4.87. It's a left-tailed test. Let's calculate it. So based on this result, I get a test statistic of negative 2.38. So it's more than 2 standard deviations below the mean. That p-value is pretty low. It's less than it's less than the 1%. Oh, is it less than the 1%? Oh, what was it? 1%? Let's see. Where is my book here? Gotta get my window out of the way here so I can see the electronic book here. Here we go. So it's a 1% level, and if I'm looking at that p-value, that's not less than 1%. That's 1.27%. Make that a decimal. So we can't, even though that one sample showed it was lower, the average, that 1 point estimate was lower, it's not significantly lower based on that level of significance. So we can't reject HO in this case. It's a good thing because I'm questioning whether this is the right test or not. So then how do we make a decision in context? Well, if you use that spreadsheet or that flow chart that I've been showing you folks there, let me go find a copy of it. It's going to take me a minute. I should have had this ready. Have any of you been using, what's the name of this website? Imgur? I really like it. Somebody told me about it a few semesters ago, and I really find it handy for working with Moodle. Let's see, I think, is it on page 6? So I'm looking for one where I did not, here, it's this one. Let me erase this. So what I've got is I've got a sample that, let me get this on a bigger screen for you. There. So our claim was that it was less than it was in 2010. So it's not a condition that contained inequality. It was, if it was that it was the same as 2010, then we would have gone this route, this branch in the flow chart. But since we said the claim was not equal, the claim was less than a left-tailed test, we're going to go this chart, this branch. And did we reject HO? No, we didn't. So this is how we would word that. There's not sufficient sample evidence to support the claim that the 2010, how did we word it, that the mean CO2 emission was lower in 2010 than it was in 2004. Okay, so I hope that helps you use a flow chart. Check your conditions. This is a sample of means. So I hope that's what you were looking for.